Ready? Okay, but no, you shouldn't whisper or talk. Either one, right? Since it's a test or a quiz. Okay, so look at your first page. Okay, first section. We're going to sketch the parent graphs. Now, do you need to memorize all of the parent graphs? No, you have a what? Calculator, not cell phone. Calculator, no cell phones tomorrow. Okay, but you'll have a calculator. You don't know what it looks like? Type it in. So square root x, if you typed it in, starts at 0, goes like that.
So we're graphing those?
Yeah. Today's paper or yesterday's paper? Oh, it's over on the...
Oh, I thought you said you had it.
Oh, that was the one from yesterday I put out there. Sorry. Okay, then x squared, what's that shaped like? It's a parabola, right?
We're putting a calculator.
Yes. No, you're okay. And then remember, as Asada said, type it in the calculator. If you don't remember, no big deal. Just type it in. Okay, x cubed. Do you remember what it looks like? It's the one that's a squiggle. Okay? Next one, absolute value x. Absolute value is a v. 2 to the x is exponential growth. Okay, again, not important that you memorize that, but the graph looks like this. It goes up. Now, on the left side, what happens as my graph goes backwards? Do you remember what it keeps doing? It gets closer and closer to 0. What is that called? Horizontal asymptote. Very good. Okay? Now your log graph is the opposite of the exponential graph. So instead of having a horizontal asymptote, your log graph has a vertical asymptote. So it goes like that. Okay? So on my paper, since I have highlighters, I'm going to highlight where the asymptotes are. One of them's here, one of them is here. So if you want to put like a dotted line or something just to show that, that would be great. Okay? So the reason that we sketch those is we are going to label each one as either even, odd, or some of them are neither. So an example of a neither is square root. Okay, remember, how do you tell even or odd? You look at the ends of the graph. Does this one have both ends?
Nope.
No, it only has a front end, so this would be a neither. What about x squared, even or odd? How do we know it's even? Because both ends are the same way. Very good. Okay, what about x cubed? What type is that? Odd. Absolute value, what type is it? Even, because my graph is the same. Exponential growth, this would be an example of neither. Because they're not going opposite, but they're not going together either. So this is a neither. What about the next one?
Neither.
Also a neither. Okay? So only x squared, x cubed, absolute value, those can be even or odd. Okay? Now the next question says, circle the functions that have a range of 0 to infinity. Okay, rather than circling, I'm just going to write them down here. Okay, look at the first one. Is the range 0 to infinity?
Yes.
Yes, so square root x. Okay, let's look at the next one. X squared. Is the lowest point 0 and the highest point infinity?
Yes.
Yes, x squared. What about x cubed?
No.
Is the lowest point 0?
Yes.
No. It goes down forever and ever and ever. What's the range of this one? Negative infinity to infinity. Because this one goes down forever, this side goes up forever. So 0 to infinity is not correct for that graph. Okay, what about absolute value x? Is the lowest point 0? Highest point infinity? Okay. Okay, exponential growth graph, 2 to the x. Is the lowest point 0? Kind of. Okay, now here's the problem. Let's write the range for this one. Oh, oops, wrong one. What is the range for this one? How low can this graph go when it gets stopped? 0. Okay, but does it ever touch 0? No. So instead of putting a bracket here, what should I have? And open a parentheses. So does that fit this? No, this one has a bracket. That means it has to be closed at 0. It has to touch 0. My asymptote cannot touch 0, so I do not list that. Okay, then what about log x? Is the lowest point 0? No. So it would just be those three. Okay, next two. There's a question sort of like this on your CBA. It's not exactly the same. Okay, but it says to find the value of a when you know that f of 8a is 103. Which of those goes in the x spot? The 8a. Good. This is going to go in the x value. And then where is 103 going to go? If it's equal to 103, that's going to be your answer or your y value. So when I plug in here, I'm going to write the whole equation again. You can do it or not. But it's f of x equals 4x minus 7. When I plug in, what is f of x going to be equal to? 103. And then what am I putting in the x spot? 8a. So I'd have 4 times 8a minus 7. So this part is going in as your x value, and then the answer is going in as your y value. Then from there, you're just solving. So what is 4 times 8a? 32a. Good job. How do I get rid of the minus 7? Plus the 7 across. 103 plus 7 is 110, equal to 32a. What's my last step? Divide by 32. And 110 won't divide evenly by 32, but you would get 3.4. Now, also keep in mind that your CBA is multiple choice. So when you get to here, if you want to just plug in the different answers and see which one works, that's fine. Make sense? Okay, do we want to do 4 together, or do you want to do it on your own? Okay, so where do I plug in 4a? X value. Where do I put 301? Y value. So I'll have 301 equals, that's my f of x. Then I'll put my half, and then what's my x going to be? What's in the parentheses? Of 4a plus 15. Okay, then some of y'all, I don't know if you remember the little railroad tracks from Algebra 1. What's half of 4a? 2a. And how do I get rid of a plus 15? Minus the 15. Plus 15 minus 15 cross out with each other. 301 minus 15 is 286. And if that equals 2a, what's the last step? Divide by 2, division. Very good. 286 divided by 2, what do you get? 143. But remember, if you had an answer choice, you could just try to plug it in, see which one works. Make sense? Okay, turn the page. Okay, next one. We have a graph of f of x as shown to the right. It asks you to find the domain. Does it ask you to find the domain of f of x? No. What does this mean? Inverse. Okay, that means inverse. And if I want the domain of the inverse, what do I want for this graph? The range. Remember how it's always backwards for the inverse? So if I want the domain of the inverse, I really want the range of this graph. Okay, so let's look at our graph. Hopefully you remember range. We do the lowest y and then the highest y. What is the lowest y value for this point right here? 2. Give me the y value. 1. So this is 1. So I'd go from 1 to infinity. This is the lowest. This is the highest. Okay, what type of endpoint does infinity get? Parentheses, what about 1? Bracket, because does it actually touch 1? Yes, that's why it gets a bracket. Can it touch infinity? No, it's not a real number. Okay, now I want the range of f inverse. Then what do I really want?
The X.
Okay, really we want the domain, which is the x. Okay, so don't get tricked by that on your CBA tomorrow. Okay, so the domain is going to be left to right. So what is the leftist, pretend that's a word, okay, that the graph goes, and then the right side. I guess ist doesn't make sense. Okay, but the leftist and then the rightist. Okay, how far to the left does the graph go? -6. How far to the right does it go if I have an arrow?
Infinity.
So it would be from -6 till infinity. Does it touch -6?
Yeah.
Give it a bracket. Does it touch infinity? Give it a parenthesis.
Where's the negative?
It's the x value right here. Because remember, domain are your x's, so you should be on the x-axis. Okay? And then your range up here would be the y's. Okay? Alright, last thing, letter C. You want to sketch a graph of the inverse. If you don't remember how to do that, all you need to do is find your points and then make them backwards. So look at your graph. What is the ordered pair for right here? Give me an x and a y. Okay, -6, 1. Okay, next pretty point I see is here.
-5, 3.
-5, 3. Good job, Miriam. Okay, next one I see is here. Look, they labeled it. -2, 5. Okay, and then let's try to find one more pretty point here. What's that? 3, 7.
0, 1.
Well, you have to be on this curve, though. Okay, then what do I do with the points? I just make them backwards for the inverse. So instead of -6, 1, what is it?
1's -6.
Okay, 1, -6, boom. Next point.
3, -5.
3, -5.
5, -3.
3, -5. Okay, next one, what is it?
5, -2.
5, -2. And then 7, 3. Good job. Okay, and then I connect my graph. Boom. Now, let's look and see if our domain and range are correct. Okay, even without having the graph, we found them. Is the domain of my graph 1 to infinity? Look at the graph we drew. Is it 1 to infinity for the x's? Yeah, where does it start? At 1, how far does it go? Infinity. Okay, what was the range for my graph? -6 to infinity. Does it start at -6 and then go up to infinity? So even without the graph, we could do it, but now that we've graphed it, we can make sure it's right. Make sense? Okay, the next thing that was on your CBA is transformations. You've done these 90 million times. Hopefully you remember. Okay, what does point 3 do to the front of the graph? Is it a vertical stretch or a vertical compression? Compression. Okay, point 3 is less than 1, so it gives you a vertical compression. What if it was a regular 3 stretch? So remember, 1 is the cutoff. Bigger than 1 is going to be a stretch. Smaller than 1 is a compression. Which way does -5 shift the graph? Choices are left or right.
What if it's inside?
It's right, because it's inside parentheses. So remember, this one's always the opposite. I'm going to shift 5 units right. Okay, then what about the +10? Your choices are up or down? Up. Remember, you only change the sign up 10 units. You only change the sign if it's in the parentheses with X. If it's at the back, you leave it the same. Make sense? Okay, look down at the next one. This time we have 4 changes. See if you can list them out and then we'll do it. 1, 2, 3, 4. Okay, first one, what does the negative in the front do? Normally, an x-squared graph opens up, but if I put a negative in front, how does it open? Good, so it reflects down. Now, the way that it's worded on your CBA says it's reflected across an axis. If I want to reflect down, what axis am I reflecting across? X or Y? X-axis. Okay, so think about it. If my graph was up here and I want to reflect it down, this would be the x-axis in the middle. Okay? Reflect down across the x-axis, that's because of the negative. What about the 3.2? Is that a vertical stretch or a vertical compression? 3.2, bigger than 1 or smaller than 1? 3.2 is bigger than 1, right? So that makes it a stretch. Okay, then my next one, I have a +1 on the inside. What does that do? Which way? Left. How many units? 1 unit. It's just whatever the number is. And then my -7 at the back, what does that do?
Goes down.
Down. And it would be 7 units. Okay? So a negative in front reflects it. The number tells you stretch or compression. Number inside is left or right. Number at the back is up or down. You should already have notes on that from when we covered it, but it's been a while. Okay, turn the page when you're ready. Okay, we are going to come back to these. We've been doing this forever. So we're going to skip. We'll come back. Okay, go to this one right here. Okay, take a look at number 9. So on your CBA, there's a question kind of similar to this. Do you remember G of H of X like that? Okay, what did we do? We did G of H of X. You remember that? All that means is that you are going to plug your H of X formula into G's X value. You are going to plug the H of X formula that they give you into the X in G. So, look right here. It says that G of H of X is supposed to be F, which is this. This is the answer I want. Okay, so I'm going to put a little star next to this. This is what I want. Let's see which of these combinations will give me that. I'm going to start with B. Look at B. If I circle H of X and I put it where X is. So I'm going to replace my X with a 4X plus 3. 4X plus 3. Okay, now what was happening to the X? Because that's my X now. It was cubed. And then what was behind it? A +1. Is that the answer that I want?
Yeah.
Yeah. So then could those be the functions that when I plug one into the other, I get this? Sure. Okay, now let's try the first one. Let's go back to A. I'm going to circle this. I'm going to replace it where the X is right here. So I have 4 times, then my X is there, I'm putting my X3 plus 1, plus 3, then I'm putting it in a cubic root. So I'm literally taking this exact formula, but I'm just taking my X out, and I'm putting this in instead. This is what I want. Is that what I want? No, it doesn't look the same at all, right? You have a random cubic root that's not supposed to be there. So this is not what I want. So that would be a no. Now, take a look at C. What am I plugging in? What's my H of X? 2X. Where am I going to put it? Where the X is. So now look what I have. 2 parentheses 2X plus 3 cubed plus 1. I'm keeping all of the outside of the formula the same. The only thing I'm doing is I'm taking the X out and I'm putting a 2X in instead. Now look at that very carefully. Is that what I want?
Oh.
Yes.
Yeah.
Why is it really what I want? What's 2 times 2X the same as? 4X, and that's what I wanted. Plus 3, check, got it. Got the little cubed and the plus 1, got it. So that's a yes. So that's a 4X plus 3 cubed plus 1. That's a check. So yes, those could be the right numbers. Okay, letter D, last one. Circle your h of x function. We're going to plug it in where the x is. So instead of an x plus 1, now it's a this crap plus 1. Because that's taking the spot of my x. So I have 4x plus 3 squared plus 1. Is that what I wanted to get all along? Yes.
Wait.
So that is going in the spot where my x was. Make sense? Not hard? Okay. Alright. Last kind of old thing, and then we'll go back and do the other graphs that we've already been doing. Okay, look at your next section. Okay, you have a freaking long equation, and it tells you that that equation tells you how many mosquitoes there are in North America. Then it says, what is the value of x where f of x is 30,000? What could you do if you had a calculator? You would not want to solve that by hand. Where would I type it into? Y equals, so you can just watch or type it in on yours. Okay, so I need 0.051 x up to the 4 plus 2.184 x up to the 3 plus 340.5 x squared minus 1502x plus 20,100. Okay, and I will warn you, the one on your test like this is just really long for no reason, or just like this. Okay, but then how many mosquitoes do I want? 30,000. Where can I see a list of all the different numbers of mosquitoes in the table? So I'm going to come here, and then I'm going to look to see when there are 30,000 mosquitoes. Okay, easiest way to do it. So look at, let me resume this. Okay, at 5 years, how many mosquitoes do I have? 21,000. How many do I want? 30,000. That's not enough. Okay, then I will have 23,000. Is that how many I want? What about 27,000? What about 31,000? Yes. So how many years did that take? 8 years. Got it? Okay, so not hard as long as you know how to use the calculator. So I would say x has to equal 8. Now, then it says, what year is that going to be? Well, I scribbled all over it on mine, but when do I start counting the years from? It says it right here. Since 2010. So if I want 8 years later, after 2010, what year would that be? 2018. Make sense? Good. Okay, last one like that. What are you going to do with the equation? Okay, so you do this one. This one's not so bad. What number are you looking for in the y column of your chart? 60. Okay, so you have the equation here. You're going to type it into y equals, and then look for 60 in the table. Now, which column should 60 be in, x or y? Y, and you're looking to find the x. Okay? It was what?
2.
Perfect. Okay, so I just typed mine in right here. Okay, then I go into my table. I'm looking for 60, bam, it's right there at 2. Easy? Okay. Alright, flip back. We skipped one page. Let's go back and do it. Okay, and then you'll have your review all the way done. You shouldn't have any homework. Okay, flip over to the back side. Let's do graph 8 first. This one right here. Okay, what does decreasing mean if the function is decreasing?
Go down.
Okay, your y values are going down. Now, which direction do you have to read the graph? Because technically, if I go this way, that's going down, right? But you have to read it left to right. So, for this part of my graph, I'll highlight it in pink. Okay, is my graph going up or down? Watch me trace it. I start at the negative infinity. I come to positive infinity. Is that increasing or decreasing? This side is increasing. Okay, then what do I have at 2, it looks like? What happens at 2? What's that called? Vertical asymptote. Okay, then after the asymptote, I have to pick up my pencil again. I'm going to pick a different color. We'll do orange. Okay, I start up here. Am I decreasing?
Yeah.
Yes. The orange side counts as decreasing because what are my y values doing? They're getting smaller. So I would say from, where did my asymptote start? 2 until infinity. Now, some of you guys, I'm almost done grading y'all's tests. You have to break up at the hole. So when I get to this hole, I can't say from 2 to infinity. Where do I need to stop? 3. So I'm going to go from 2 to 3, stop, there's an asymptote, and then 3 to infinity. Okay? So you always break up around 2 types of things, holes and asymptotes. Now, if you were looking at it in the calculator, how would you know what to break up around? What will it say in the table? Error, 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 right? So I'd go from 2 to 3, stop, there's a hole, then 3 to infinity. Okay? Next one, for my domain, I don't just want the orange side, I want the pink side too. How far back does the pink side go? Till when? For domain is x. Negative infinity. How far forward does the pink side go? To what x? 2. Can I cross 2? Leave it open. Now I'm on the orange chunk of the graph. Orange comes all the way back to 2, but it can never touch it. So bracket or parentheses? Parentheses. And then how far do I go before I have to stop again? 3. Why do I have to stop at 3? Because there's a hole. Okay, then I keep going on my orange graph. From here, how far does it go forward? Infinity. So 3 till infinity. Now notice in your domain though, what 2 numbers did you break up around? The asymptote at 2 and then the hole that was at 3. You don't have to break up on anything else though. Okay? Next one, where do we say our vertical asymptote is? X equals what? 2. Okay, next one, as x approaches 2 minus, what does that mean? Which side? Left side. So I'm looking at my graph. Which side is the left, pink or orange? Pink side. And what's the pink side doing towards the asymptote? Up or down? Up, which is towards infinity. Okay, now look on the right side. So instead of coming up on the pink side, I want to come on the orange side towards the line. Which way is that side going? Up as well, so it will also be infinity. So both of these asymptote up. Both sides asymptote up. What if one side had gone down? What would you put? Negative infinity. Very good. Okay, what about as x approaches 3 from the left and then 3 from the right? Well, as I come down here from the left side, what y value am I getting closer to? What y value is that? 2. What about as I trace in from the right side towards the hole? 2. So remember, it's only going to be weird if it's an infinity. Okay, if it's just a regular hole, you don't care that there's a hole there. You're looking at the y value. Okay, then last one, x to negative infinity. What am I looking for in the graph? The left end. Very good. And remember, you're looking for what the y value is getting closer to. So as my graph continues out here forever and ever, what is it getting closer to? The y value is 0. Because remember, the x-axis is 0, right, for y values. Okay, now what about as I go to the right end of the graph? What about as I look at this end? What's it getting closer to? 0 as well. Okay? Alright, one more left. Go up. Okay, how many asymptotes on graph 7? The last question.
3.
Okay, give me the 2 vertical ones first. Because you're right, there are technically 3. Where are my 2 vertical asymptotes? Okay, negative 2 and 1. Very good. So I have vertical asymptotes at x equals minus 2 and x equals 1. 1 here, 1 here. Now, somebody said there are 3 asymptotes altogether. That's correct. What other type of asymptote is there? Horizontal, very good. So if you want to draw that one in, there's also a horizontal asymptote at y equals 0 since it's the x-axis. Okay? Now look at your graph. Let's see its domain. We're going to do that first. How far back? Now, actually, let me ask this too. How many pieces does my graph have? I have one here that goes down towards the asymptote. Then I have one here in the middle. How many pieces is that so far? 2. And then I have one more over here. That's piece number 3. And every time that I have an asymptote, I have to break up my domain. So my first blue piece, how far back does it go? How far back does it go for x because we're doing domain? Negative infinity. And then when does that piece get stopped by an asymptote? At negative 2. Union. Now I'm doing the piece in the middle, this green piece. How far back can the green piece reach? What x value?
1.
Negative 2. But can it touch it? No. Now going forward, how far can it go? 1. Because on this side, it gets all the way close to 1, but can it ever get there? So leave it open. Okay, then the last little piece, this orange chunk over here, how far back can the orange chunk reach? 1. Can it ever get to 1? No. So 1 till infinity. Okay? Make sense? Okay, next one, let's do the asymptotes. Okay, so look at negative 2 from the left, and then negative 2 from the right. Remember, this is the left side. That's the right side. Negative 2 is here. If I'm on the left side, what color am I on? Green or blue? Blue. And what is blue doing as I get close to the line? Going up or down? So what do I put? Negative infinity. Okay, go back to your equation at negative 2. I want to be on the right side. Which color am I on? Green or blue? Green. What is green doing as I get close to the asymptote at the top? Up to infinity. So that side's up, that side is down. Okay, next one, I have another asymptote at 1. Here's 1. Left side is down. What's the right side? Up. So it would be down and up. Okay, last 2. Look at your x approaching. When it's going to infinity, you're looking at the end behavior. Remember, we talked about that word just means asymptote. As I go to the left forever, what am I getting closer to? Where's my orange line at? 0. As I go forward on the graph from this side, what am I getting closer to? 0. So both of my y values are approaching 0, or the x-axis. Because remember, that's the same. Okay? And then I guess let's go back and do D. F of x greater than 0, what are you looking for on the graph? Where does it need to be? Above or below for greater than 0? I'm looking for where the graph is above the x-axis. And there are 2 chunks where it's above. Where is it above on green? That side. And then where is it above on orange? The whole thing. So if I want to be above, I'd say from negative 2 until a half, union, and then I'd say from 1 until infinity. Make sense? And then also think about, why am I leaving 1 with the parentheses? Because what happens at 1? I can't touch it. That's why it has to stay open. Same thing at negative 2. I can't touch it. And then I stop here because then I go below. Make sense? All right. Good job. So I'm not going to take your CBA reviews up until tomorrow, so that if you want to study, you can. And then tomorrow I'll be here for tutoring in the morning. If you want to come, just let me know. Oh, good. Okay, real quick, the increasing, does this one ever increase? Watch. Remember, I have to start here. What am I doing? Increasing or decreasing?
Decreasing.
What am I doing here?
Decreasing.
What am I doing here? So if it's never increasing, what would you put?
None.
Empty set, or you could put none. Okay, because it's going downhill the whole time. Yeah.
Do you mind if I leave a little early? My car is flat and I want to take it to the shop before the traffic is bad. Thank you.